Chapter 23, Problem 38. In a series RLC circuit, the generator is set to a frequency that is not the resonant frequency. This non-resonant frequency is such that the ratio of the inductive reactance to the capacitive reactance of the circuit is observed to be 5.64. The resonant frequency is 210 Hz. What is the frequency of the generator? So for this problem, I started off with these three equations right here. This right here is the capacitive reactance, this right here is the frequency, and this C stands for the capacitance. This right here is the inductive reactance, and this is the frequency again, and this is the inductive reactance. And this right here is the resonant frequency, and this right here is the equation. And I hope you recognize that we just saw the L and C from these two previous equations. And going back to the problem, it said that the ratio of the inductive reactance to the ratio of the capacitive reactance was equal to a value of 5.64. Another way to represent this is by doing 2 pi FL, so the inductive reactance divided by the capacitive reactance. This is what it's meant by the ratio of, and it is set to 5.64. Another way to represent this is doing 2 pi FL times 2 pi FC, or the capacitance, which is equal to 5.64. Right here I'm just rewriting the equation. And now I'm just going to do a little more algebra to clean up this equation over here, and to bring certain values over to the right side of the equation, and it'll make it easier to solve this problem. So from here, I'm going to simplify it as 4 pi squared f squared LC is equal to 5.64. And then I'm going to divide each side by 4 pi squared f squared in order to get LC by itself. And then my ultimate goal is to get this LC right here to match the LC in this equation right here, because we were given the resonant frequency in the problem, and that was equal to 210 Hz. So let me just rewrite that right here. 210 Hz is equal to 2 pi LC. So I'm just rewriting the equation because we were given the resonant frequency, and our ultimate goal is to find the frequency of the generator, or this F right here. So just keep that in mind. And so in order to get this LC to look like this LC over here, what I'm going to do is take the square root of both sides, and so I'm going to end up with LC is equal to square root of 5.64 over 2 pi F, because everything right here is squared, and of course 2 squared is 4. And so now that I have the square root of LC over here, I'm going to plug in this square root of LC over to this square root of LC right here, and I guess I'll do that right here. So 210 Hz, or the resonant frequency, is equal to 1 over 2 pi times LC. I'm just going to plug this in. So I'm going to bring this over here. 5.64, and this is what we just derived, over 2 pi F. And so I am just going to get rid of the 2 pi's right here. This is all in the denominator. 210 Hz is equal to 1 divided by, once the 2 pi's are canceled off, you're only left with square root of 5.64 divided by F. Because this is 1 over the square root of 5.64 divided by F, I'm going to rewrite it as 210 Hz is equal to F divided by square root of 5.64. And then in order to find F, I'm just going to multiply both sides by the square root of 5.64. Hertz is equal to F. And you should get a final answer of 498 Hertz is equal to the frequency of the generator. For this problem, I was a little confused initially, but what I basically did is just follow the units, and given these three initial equations right here, I knew that I was looking for F because I had all of the other values. We were given the resonant frequency, which was equal to 210 hertz, and I knew that if I divided the inductive reactance by the capacitive reactance, I could find a way to isolate LC over here and make it into a root LC, and I would just plug in this root LC over here into this equation over here. And I knew that if I had the resonant frequency, all I would have to look for in the problem would be this value right here of F, or the frequency of the generator. And the main thing to keep in mind is just to keep track of your numbers, because it's just a lot of algebraic manipulation here. And again, this is all in the denominator if it's not clear. And once I cancel off the 2 pi's, I have 1 divided by 5.64 over F. And so I just rewrote that by taking the reciprocal. So 210 hertz is equal to 1 divided by square root of 5.64 divided by F. And then, of course, I just multiplied each side by the square root of 5.64. And I got the final answer of, if you can't see this, 498 hertz is equal to the frequency of the generator.